Good evening, everyone.
Good evening.
So today we are going to discuss pumps, refrigeration, and workshop. So all the questions are taken from IMS testimonials that are going to be asked in IMS interviews. So let's just start the session. The first topic is refrigeration. Wait, still people are joining. So yeah, let's just start it. So the first question from refrigeration. Components of VCRS. Can somebody please start? Components of VCRS?
Compressor,
Yes.
condenser, and then dryer,
Yes.
thermostatic expansion valve, evaporator.
Okay.
And then sensing bulb.
Okay. So, can you explain the VCRS system?
Yeah. I start with the compressor. Low pressure, low temperature, air is coming, saturated air is coming to the compressor, and it isentropically compressed into high pressure, high temperature, superheated vapor, and then it goes to condenser. The superheated vapor is converted into saturated liquid, and then it passes through the dryer, which filter the moisture present in the saturated liquid, and it goes to the thermostatic expansion valve. High pressure, high temperature is isentropically expands, and then velocity increases, pressure energy decreases, meanwhile temperature also decreases. The mixture of liquid and vapor, low pressure, low temperature is passes the thermostatic expansion valve, and it goes to the evaporator. Evaporator will observe the heat isobarically, observe the heat, and then it converted into saturated vapor, and it senses through the sensing bulb, and again it passes through the compressor.
Anybody else wants to answer this question? Anybody? It's all right. Just speak up.
First, can I try?
Yeah, sure.
Okay, so there are four major components of a VCRS system. First one is compressor, then there's condenser, then there is thermostatic expansion valve, and there is evaporator. Okay, so first of all, the liquid refrigerant, gaseous refrigerant comes into the compressor and gets compressed. Then in high pressure, high temperature compressed refrigerant passes through the condenser where it gives off some heat and gets converted into the liquid. After that, this condensed liquid, then condensed liquid at high pressure and low temperature goes through the thermostatic expansion valve where it passes through a small orifice at a control rate after throttling. So at the exit of thermostatic expansion valve, the refrigerant is in liquid and vapor mixture state. Then this liquid and vapor mixture goes to the evaporator where it absorbs the heat from the cooling chamber and gets converted into uh, completely gaseous state. We maintain some degree of superheat somewhere around 5 degrees. So to ensure that the refrigerant entering the compressor is in the gaseous phase only. So it will avoid like avoid the damage to the compressor by compressing the liquid. Also, thermostatic expansion valve is connected at the outlet of that evaporator to a sensing bulb. So it senses the temperature at the outlet of the evaporator and accordingly adjusts the flow uh, into the expansion valve and regulates the amount of liquid going through the evaporator.
I think you have explained everything. It was a nice answer. And Ashok, I think you have not mentioned in dryer the silica gel. You can also add that part while explaining the dryer. And anybody else wants to explain this answer? Or should we go to the cross questions of VCRS system?
Should I try it once?
Yeah, sure.
Yeah, I will start with the compressor.
Yeah.
First of all, low temperature, low vapor refrigerant will enter into the compressor. Then isentropically, the refrigerant will compress with the help of a compressor. Then it will convert it into high temperature, high pressure vapor refrigerant. Then it will be passed through the condenser where isobaric condensation will be taking place, heat rejection. So the refrigerant will be converted into slightly lower temperature and high pressure refrigerant. Then it will be passes through the dryer where it contains silica gel. The moisture present in the liquid refrigerant will be absorbed in the dryer, and then it is allowed to pass through the expansion wall. The expansion wall is something like an orifice where isenthalpic expansion takes place, due to which the liquid refrigerant will be converted into low temperature, low pressure mixed to vapor refrigerant. Like 80% will be liquid and 20% will be vapor. Then it is this refrigerant will be allowed to pass through the evaporator where it absorb all the heat from the evaporator, and then the super heating of the vapor refrigerant will be take place about 5 to 7 degrees Celsius. Then it is allowed to pass through the compressor, but before that the sensing bulb will sense the refrigerant that only the vapor refrigerant should be allowed to pass through the compressor to the compressor. So it is connected to the thermostatic expansion valve via a capillary tube. So it will control the flow of refrigerant to the evaporator. That's it.
Your answer was good. You have explained very well. So should we move on to the cross questions, or anybody else want to explain this part?
SURFRAZ, can you please be a little louder?
Yeah. Should we move to the next part, or anybody else wants to answer this part?
Go to next part.
Okay. So can you tell me what's the working of the sensing bulb? Anybody? Gaurav, yeah?
Sensing bulb is a device which is fitted after the evaporator, which senses the degree of superheat of the refrigerant, vapor refrigerant, and it will control the thermostatic expansion valve for open and closing the valve to regulate the flow of the refrigerant in the thermostatic expansion valve. In the sensing bulb, it is in the sensing bulb, the same refrigerant will be present inside the when it will be getting the more superheat, it will be expand inside, and it is a closed vessel. That's why it will be expand and creates a pressure which react on the thermostatic expansion valve diaphragm, and the diaphragm will be push the pin, and the pin will also push the poppet valve, and it will be open and close as per required of the temperature control. That is the
Working, yeah. So when the refrigerant in the sensing bulb will vaporize, the pressure will increase. So since the pressure is increasing, the pressure will also increase in the capillary tube which is connected to the thermostatic expansion valve. So the refrigerant will flow towards the thermostatic expansion valve, and then this refrigerant will push the diaphragm that is present in the thermostatic expansion valve. Anybody else also wants to try this answer?
Can I try?
Yeah, please.
In a sensing bulb is located after the evaporator, and it will sense the it will sense only it will sense the vapor refrigerant only. If there is a it won't allow the liquid refrigerant to pass through it, and then it will sense the temperature. If the temperature is higher than the desired temperature, means it will send the signal to thermostatic expansion valve to allow more refrigerant. If the temperature is less than the desired temperature, the thermostatic expansion valve is compressed. This is how sensing bulb work.
So, anybody else want to answer, or should we go to the next patient?
Can I?
Yeah, sure.
Sensing bulb is a bulb which ensures that the refrigerant must be in vapor state. When the refrigerant is in liquid state, it sends the refrigerant through the capillary tube to the thermostatic expansion valve. It acts like a throttle device which which regulates the refrigerant. That's it.
I think you were explaining thermostatic expansion valve, right?
Yes.
Yeah. Okay. So, we also have Shashank here. Shashank, do you have any input in this answers?
No, bro, it is simple, fine. But there can be cross question like, what if you maintain extra superheat? Like,
Yes. Please add those cross questions.
yeah, now you're telling that some people said that you will maintain around 5 to 7 degree of superheat.
Yeah.
But here cross question can be like, what if you maintain like more superheat?
Yes.
These kind of questions can be asked.
Yes. Can please anybody answer? Gaurav, Kamlesh.
If you're
Hello.
maintaining the degree of superheat more than a certain limit, then it will add up the required compressor work to compress that superheated refrigerant back to the liquid state.
Hello.
Yeah, Gaurav. Yes.
Yes, it is a measuring of the superheat we can be give inside the compressor. It is as per required hour it will increasing the volumetric efficiency. When the more superheated vapor, the volumetric efficiency will be decreased there. That's why a certain amount of vapor superheat will calculate before the pump before the refrigeration making. Then this superheated will be controlled by that system.
It will be controlled by the.
Controlled by the sensing bulb and system.
Okay. So, what's the working of the thermostatic expansion valve? Can anybody answer?
It is isentropic expansion where the pressure and temperature is decreases and then velocity of the refrigerant is increases.
It acts like a orifice where the refrigerant will have a sudden pressure drop and the temperature drop takes place, and it changes its liquid state to liquid plus vapor mixture state, that is 80 to 80% of liquid and 20% of vapor.
Okay. So, how is the pressure drop taking place?
Yeah, it's orifice. It has a uh, minimum diameter.
Yes. When the
I
refrigerant
think.
passes through the orifice, the volume increases.
Yes, the sudden yes,
This
volume.
a sudden increase in volume takes place, due to which the pressure
So
decreases.
yeah, pressure decreases.
Yeah, and it acts like a throttling device. You said it acts like a orifice. You can say that it acts like a throttling device, and it has an orifice. So when the refrigerant passes through the orifice, due to the sudden enlargement in the volume, the pressure drop takes place.
Okay.
Anybody else want to answer?
Can I?
Yeah, please go on.
The thermostatic valve is suddenly decreasing of the high pressure and high temperature vapor into the mixture of low temperature and low volume, low temperature and low pressure vapor mixture.
Yeah, your answer should be a little bit more detailed. You just said very short answer. You just make it a little bit more longer. Think it will be much better if you little bit make it more longer.
Okay.
Like because of the volume enlargement, the pressure is dropping, and then the temperature is dropping. That way. Kamlesh, would you like to answer it?
I think let's go to the next question.
Yeah, sure.
Yeah. Okay, just a minute.
Yeah.
Before we move on to the next question, we were discussing super heat. So I would like to add one question. Can anyone explain the effect of subcooling on the refrigeration effect?
Yes. Yes. Can anyone explain the effect of subcooling?
If subcooling will add, then refrigerant capacity will increase.
Yeah. That's true.
Anybody else wants to answer? Yes, the session is being recorded and it will be uploaded in YouTube till next day.
I think the work done will be reduced.
Yes, the work done will be reduced. Can you explain fully?
Yeah. Said work done. Can you please explain this work done criteria, please?
Yeah, Abdul, hello.
Sorry, I'm unable to recalling that whole process.
Okay, so as far as I know,
Yeah.
so
Yeah, you can
if you see
explain.
the pH diagram, okay, then if you're subcooling the refrigerant, then the point 3 which we have, it will be going towards the left, like towards the origin side, and also the cooling effect will be increased. I'm a little bit confused about the how work done is being said, but if you find anything about it, please share it on the group.
Can I told something?
Yes,
Yeah,
please.
sure.
In vapor refrigerant, the subcooling decreases the temperature of the vapor refrigerant. The refrigerant, liquid refrigerant. It increases the COP, means the coefficient of the performance of the refrigeration system. Here, when the passes through the expansion valve, some of the superheat will be converted into vapor state. This heat will be converted the liquid to vapor. That's why when the subcooling will be doing there, the heat will be already decreases. The refrigerant heat can be converted the more amount of the liquid cooled refrigerant inside the evaporator. That can be more suck the heat from the evaporator coil
Cooling chamber.
to yes, that is.
Okay. So I think instead of yeah, sure,
please.
sure, go ahead.
Please, we can.
Where does the subcooling process is occurring?
Okay,
When the
so
refrigerant
wait,
is passing.
I'll share an image.
Yeah. Wait, have I given you the host for sharing?
Just a minute. I've shared the image on the group.
Yeah.
Everyone can find it.
The subcooling will take place when the refrigerant will pass through the condenser, right?
Yeah, right.
If
It will be
temperature,
happening in the condenser.
yeah, if the suppose the temperature of the seawater that is present is lesser than the
Before
required.
leaving it will happen before leaving the condenser.
Yeah, of
Yeah,
course.
yeah, before leaving the condenser. Oh,
In the condenser. Okay. I think I've read it on the wrong book.
so I think I will just go to the next question.
Yeah, sure.
How cooling is produced in VCRS? Can anybody explain? Yes, guys. Ashok, Abdul.
When does compressor is compressed and then it produces superheated vapor, and then it goes to the condenser while it superheated, and then superheated vapor is converted into saturated vapor, and then saturated vapor is converted into saturated liquid, which is passes through the dryer. The silica gel will absorb the moisturous content in the saturated liquid, which again passes through the thermostatic expansion valve, high pressure, high temperature, orifice meter, which sudden increase in diameter, there is a velocity increases, pressure energy temperature decreases, and then vapor plus liquid refrigerant is processed through. This is how cooling process in thermostatic expansion valve occurs.
What was the question for this answer?
The question he explained the whole refrigeration cycle. The question was how is the cooling takes place in reefer system.
Yeah.
Yes. Anybody else wants to answer?
Anyone, please? Because I have an answer, but I'm not super confident about it.
Gaurav?
Yes, I can go.
Yeah, sure.
After thermostatic expansion valve, the liquid plus vapor refrigerant enters to the evaporator, which is acts as a heat exchanger. The hot air from the fish room or else the closed room, the I mean the liquid plus vapor refrigerant is converted into vapor by absorbing the hot hot air. So the hot air is condensed to the cold air. So it is sent to the closed space, which we have to remove the remove the heat from the substance, and we can cool it down by lowering temperatures. Lowering temperature. That's it. It's not efficient. Sorry.
Yeah, but the answer was all right. If somebody is asking the cooling effect, then we just need to explain the evaporator part. So this is all right. Which refrigerants are?
So
Yeah, please.
so the answer for this question should be like confined to this evaporator part only, right?
Yeah.
Because I have some doubt because
The
by
main
this
part
question,
will be
what I'm
caused by the thermostatic expansion valve.
yeah,
The
exactly.
thermostatic
Because what I'm thinking here is the question which actually wants to know about how exactly the liquid is being cooled. Okay, so my answer for this question is we are compressing the vapors, vapor refrigerant. Okay, then it passes through the condenser where it rejects some of its heat to the seawater or cooling water. Okay, after that, it enters passes through thermostatic expansion valve where it undergoes throttling process, and the temperature drops. These are the two main processes where the temperature of the refrigerant is being reduced. So as this cooled refrigerant enters the evaporator, it absorbs the heat from the cooling chamber and gets superheated or gets converted into the vapors and then gets superheated. And then again, the cycle continues as it enters the compressor.
So you're saying that we should explain the whole part, right?
No, not the whole part, but the emphasis should be on the condenser and the thermostatic expansion valve. Correct me if I'm wrong.
No. I think you should explain like the compressor, the condenser, and the thermostatic expansion valve. But we should not go into full explanation, just the main points, and then explain how the cooling effect is taking place after the thermostatic expansion valve. When the refrigerant is passing, it's getting cooled down. Correct? Am I right?
Right. Exactly. Yeah.
So the next question is, which refrigerants are used in RAC? Yes. Can anybody answer?
R134A, R125, R22, R404. This much I know.
R143 also is there.
R134A.
R12. Yeah,
excuse me. This R12 and R22 both are banned on board, so you cannot use it.
Yeah, I was about to come there. Mostly
Yes,
these refrigerant are being replaced by the newer refrigerant, HFCs.
Okay.
Right.
Yes. So everybody has got the answer.
Yes,
If this question is asked, should we explain like on board or the domestic refrigerants too? Like in this question, it was mentioned that whatever is used in RAC, or we can say both, right? Refrigerants that are used in domestic refrigerators.
Yeah. If someone asks what are the refrigerant used on board ship, then we can say that R134A and 125.
Yeah.
But if he says what are the refrigerants that are being used in the complete VCRS cycle, then we can say both, I think.
Yeah. And it will be much better if you will mention that these refrigerants R134A is used on board, and these refrigerants are used in domestic refrigerators.
So what about the R4110A in the RAC?
Shashank, do you have any idea on R1? What was
R410A is used.
410A.
Used in the RAC.
Yeah, it is used.
It is used in on board, right?
Yeah, R410A is used on board, bro.
Okay. So on board we can say two refrigerants are used: 134A, R134A, and
R404 and 410.
R404 and R410. Okay.
I can say that R12 is replaced by R410 and R22 is replaced by R134A. Am I correct?
Yes, right.
Yeah, bro, right.
It's right? Okay. So the next question will be, how will you charge the refrigerant? Can anybody please answer? How will you charge the refrigerant? Lot of guys are there, but I think only few are answering. Guys, please answer.
I was not confident that I know something. We reduce this, by lowering the pressure, we can, sorry, I'm not getting
It's
that.
all right. On board, how it is done, Shashank will explain. But before he can explain, can anybody else answer this question?
Yes, after condenser, it can be a channel or line which will be from where it will be charged when the refrigerant will be less inside the system. And another one process can be happened before the compressor, the vapor refrigerant will be can put inside the line. I don't know proper the what will be happening in the onboard seat. So some can explain that.
Bro, can you explain what happens in onboard? Hello, Susank, am I audible? Susank, I think he's not able to hear me. Yes. Susank, are you hearing me?
Can we experience this question at the
Hello.
interview?
Yeah.
See, this question is written in our IMS testimonial, and
Okay.
I think it is asked in the
Sorry.
interviews. That's why this question is written here, and I think you should prepare well for this answer too, for this question.
Okay.
Susank, can you explain
Hello, can you hear?
anything on board how the refrigerant is charged?
You can hear me right now.
Yeah, now you're audible. Yeah.
Hello.
Yes, now you're audible.
See, there are charging one. Yeah, okay. There are two other with charging. You can vapor charging
I think your voice is breaking.
side of compressor.
You are not audible, Susank.
Yeah, your voice is breaking.
Oh, it's raining here. Sorry.
Yeah, it's all right. So I think we are keeping this question for last. Then we will explain. Then he will explain this part. All right. So we will just move forward.
Okay. Okay.
What are the RAC components that are fitted?
It was the same as VCRS, right?
I think two more components are added, right?
Yeah, it is add up with streamline
Yeah.
and humidification.
Yes. Correct.
Humidification process take
Yeah.
place.
That's the same. These two things are added.
Yeah.
Susank, it's all
Go
right.
ahead.
If you will be able to speak at last, then it will be all right. Otherwise, we'll discuss this question next part because I also don't know this answer. Does anyone else knows the answer how it is charged? Tobles?
No, bro. I don't have clear idea about it.
Yeah, it's all. I have also tried to charge that answer, but I got like for domestic refrigerators and all, but I couldn't get a proper answer. It's all. I will discuss it later on.
Yeah.
Why R600 is used in domestic refrigerator? Can anybody tell me?
R600 is the lesser global warming potential and less ozone deflection potential.
Okay, we have 2 points.
It has low boiling point. It is low condensing pressure, and it has a low global warming potential, and it has low ozone depletion, ozone depleting, and it is non-toxic, and it is available at cheap. And yeah, that's it. Coming to this, its disadvantages. It is flammable, and yeah, that's it.
So it just has one disadvantage that it is flammable, right?
Yes, it is flammable.
Okay. So everybody has got the answer, right?
Yep.
Okay. How will you troubleshoot a leakage in a refrigerant pipeline?
By using halide torch or using a soap solution, or yeah, that's it.
but to detect the leakage, we can use a halide torch or a soap solution, right? But for
Yes.
troubleshooting,
I'm not aware about that.
yeah,
It depends on where it's exactly happening. I think
in the question, I think here it's written in refrigerant pipeline.
mhm. No.
Like
If it's there in the
halogen gas
valve,
detector.
Yeah, now I can pick it.
yeah. So I
That
was
will
saying
be
if
only used, no? Soap bubble test only will be used, right, for the pipelines.
To detect it, we will be using halide torch and soap solution, correct?
Yeah, and for troubleshooting also same, right?
For troubleshooting, I also don't know the answer how the troubleshooting is taking place.
Troubleshooting means that only, no?
No, to make
Where
it.
where does the leakage, where does the leakage is there? Like we can find out from that
Finding the
only.
leakage, where the leakage will be.
Okay,
Kamlesh, what you feel? Same thing, right?
is it the same thing?
yeah, actually I
Kamlesh,
was trying to guess the answer.
Okay, the same thing.
That we'll just try to like if there's leakage in the valves and connectors, then we'll try to tight it and see if it's stopping. If not, we'll replace the component. And if it
but
is between the lines, I think it can be solved by brazing or something.
Okay, yeah,
But
that's the
not
thing. Like
100%.
if there will be leakage, how will you stop it?
I think safety valves, I mean safety devices are comes into play when the troubleshoot occurs. Like working of solenoid valve and yeah, like that.
Okay,
Automatically it trips, and we need to manually reset the troubleshoot by detecting.
okay,
Maybe this could be the answer. I think.
You
okay.
got anything on that, Surprise?
No, I don't have anything. But actually, I have wrote something else, like how to troubleshoot it. But currently, I don't have
Okay,
that notes. But I will share it. I will find it and I will
sure, sure.
share it. Yeah. So the refrigeration questions from the IMS testimonial are finished. Do you have any other questions? You can please add it.
Yeah, I have a doubt.
Yes.
In sensing bulb, uh, it will sense the temperature of the refrigerant and how the out will how it will send the signal to the thermostatic expansion valve and how the regulation between thermostatic expansion valve and then sensing bulb.
So I will try to say the answer. Please correct me if I am wrong. So the sensing bulb is a confined space. It has the same refrigerant, right? That is flowing in the refrigeration system. So when it senses the degree of superheat, the refrigerant in the thermostatic expansion valve vaporizes. So the pressure increases since it is in a confined space. And as the pressure is increasing, it's connected to the thermostatic expansion valve, right? So the pressure is increasing in the capillary tube too, as it is connected to the expansion valve with the capillary tube, and then the refrigerant is flowing towards the thermostatic expansion valve that will hit the diaphragm of the thermostatic expansion valve, and then the spring and the poppet valve will go down and open the orifice more. Am I correct, Kamlesh?
Yeah, I'm just trying to find the diagram for thermostatic expansion valve. Just give me 2 minutes so that I can share it over the
Yes,
screen.
yes.
yeah, you were correct.
Okay.
Give me a minute.
I also had an image diagram. It was a very good diagram. I'm sharing. I'll be sharing it in the group.
Okay. Do I have permission to group share? Yes, I can.
Yeah, I think I have already done it. You can share, right?
Yeah.
Yeah.
Can you see the screen?
Yes, now.
So see. Okay, so let me see where is the sensing bulb. Okay, so this is like refrigerant coming in. This is the refrigerant going out. Okay, this is our orifice. This is where throttling is happening. This is like let's say it's kind of a needle valve. Okay, so see if you see this is a capillary tube and bulb, right? So capillary tube goes from here and it is connected to bulb. The bulb will be located at the outside of the evaporator. Okay, so as soon as there is a like a temperature change, then the like refrigerant present inside this capillary tube and the sensing bulb will expand or contract, or what I'll say. It will, the volume will increase or decrease. Okay, is that clear?
Yeah.
Hello.
Yes.
Yeah. So this expansion or contraction of the refrigerant will have some effect on this diaphragm. Okay. So
Yes.
if it is expanding, what does it mean? Yeah, it's expanding, which means that temperature of the like refrigerant coming out of the evaporator is too much. Okay. So this will open the valve and more refrigerant will be passed through the evaporator. Okay. In order to like facilitate the more cooling effect. And as soon as the temperature drops, the valve like this diaphragm will get lifted and the valve will be closed and the flow will be reduced accordingly. So that's the general idea of how thermostatic expansion valve works.
And
Is that okay?
if the degree of superheat is reduced, then the reverse will be happening, correct?
Yeah, that's what I said. When the temperature is like load is reducing and the temperature is of the like refrigerant coming out of the evaporator is decreasing, then it will contract, the valve will, like diaphragm will move upward and the valve will close partially.
If it
I
is
think,
superheated, the spring will go upwards and then hit the diaphragm, right?
no. If the spring is going upward, okay. So what does it mean on our like chart? If you see, uh, it means we are absorbing more heat from the evaporator, okay, and our degree of superheat is increasing. So in order to facilitate, like maintain the degree of superheat, what we are doing is providing more refrigerant so that it can absorb more heat, but the degree of superheat will be managed. I think the heat exchange formula is somehow related to mass, and I don't exactly remember the formula, but I'll be posting it on the forums. Okay. So by increasing the mass, we are facilitating the heat exchange which is happening between the evaporator. So if the degree of superheat is increasing, we are allowing more flow to occur. So the degree of superheat will be reduced, and as the temperature drops below, like there is a what we say, yeah, the steam is not superheated, then we reduce the flow. So the temp like refrigerant flow reduces and the temperature increases. Is it making any sense, or you're just getting more confused?
Okay, it's clear.
Now I'm getting it. Yeah.
Is that fine?
Yeah. Does anybody has any doubt regarding the working of this one, sensing bulb and the thermostatic expansion bulb?
No.
Okay. So we will just move forward to pumps, or do we have any other questions regarding VCRS?
Yeah. I have one question. Someone mentioned dryer, right?
Dryer.
Dryer in the VCR system. Yeah.
Yeah.
So what does exactly this dryer is doing?
So the dryer.
Anyone can.
Can I try? I just please correct me if I'm wrong.
Yeah, sure.
Yeah. So the dryer is fitted after the condenser. So if there will be moisture present in the thermostatic expansion, if there will be moisture present with the refrigerant, then the dryer has silica gel in it, which will absorb the moisture, and then that refrigerant will pass to the expansion valve, right?
Okay.
But how is it absorbing the moisture?
No, it's silica gel. That's clear, but I'm not sure how the moisture is entering the system.
Yeah, I have asked this question to.
Moisture is, yes, yes,
Yes, Gaurav, please explain.
I know
Yeah,
that.
go ahead, please.
Yes, when we yes, when we are charged the refrigerant inside the line, this time some air or any substance will be entered through that. That's
Okay.
why this moisture will be present when this line. It will be that time only moisture can be come inside, or another leakage will be present. This time can already moisture can come inside.
Okay, so the only chances of moisture entering the system is either there is a leakage or some
Yeah.
If there is
careless
leakage,
handling while charging or discharging of the
Yes,
system, right?
I think during maintenance.
if
Yes.
there is if there is leakage, then the process won't happen, no,
Yes.
of refrigeration. You can't say
Okay.
leakage. You can only say while charging, I say.
Yes, I think during maintenance, the moisture can
So
be
yeah,
getting
so
added
basically
inside.
during the maintenance only, right?
Yeah, yeah, yeah.
Yeah,
I have
one
asked this
of my
question
friend asked.
to sir, but
When we charge the refrigerant,
yes, Gaurav,
Sorry.
please speak. Yeah, Gaurav.
yeah, only the maintenance time and the when yes, you are I am audible.
Yeah, yeah, yeah.
Hello.
Yeah, yeah, you are audible, Gaurav.
Yeah, when we are charged the yes, when we are charged the refrigerant, this time can be comes the moisture through this leakage. When we charge this, that is a process. The two types of process, and one is the forced process, and the one is the simple process. Two types of charging will be present there. When we charge forced process, this time no moisture will become. When we will giving the simple process, this time can be through the because their evaporator side also the low pressure will be created, due to which the atmospheric pressure also be high, due to which the some moisture will be come through this line. It will try to come through this line, but some moisture will be come. That's why the moisture will come inside the line, or due to maintenance time can come.
Yeah, I still have some doubt in the first part. Uh, and Shashank is saying that when air will be in the refrigerant system, then only moisture can occur. But air can only come inside the system when the maintenance is going on, right? Saying something, the refrigerant bottle need to be purged before filling the gas. Okay. So everything from should be removed before charging the refrigerant system. That's what you were saying, right? Okay, so before filling the bottle, the purging needs to be done of the bottle, correct? Am I right? Okay, okay. So I think
Okay,
everybody has
so roughly we can say only when we are doing the maintenance and charging, that's the only time where there are chances of moisture entering the system.
yes,
Am I
yes,
right?
yes. I have also asked this
Okay.
question to one sir. Then I have also got the same answer during the maintenance time.
Yeah, yeah. Yeah, I just wanted to make sure.
Yeah, yeah.
Uh, I've discussed this already with someone.
So does anyone
Thank you.
have
We can move ahead.
okay? Does anyone have any other questions regarding VCRS, or should we move on to pumps? Okay, then we are just moving on to pumps. Okay. So starting for the first question, can anybody explain what are the components of a pump, centrifugal pump? Anybody, guys?
Foot valve,
Yeah.
strainer,
Yeah.
impeller, and then casing, and then discharge valve, IF and impeller.
Okay. Uh, you have didn't mention a few things, I think, like the gland packing or mechanical seal, the shaft, the
Can I
motor,
tell?
the yes. Please answer. Gaurav.
Can you-
You are not audible, Gaurav.
Okay. I am starting from the strainer.
Yeah.
Strainer. Then, hello.
Yeah, now I'm hearing you.
At first, I am starting from strainer, then foot valve, then suction line, impeller, casing, priming port, air vent cock, discharge valve, and shaft, motor, mm, gland packing or mechanical seal, or wire ring, lantern ring. That is.
Okay. What is the wiring? And where is this wiring fitted? Can you answer, Gaurav?
Yes, wiring is a softer material than the parent material, which resists the wear and tear between the parent materials like shaft or the casing and the shaft and the impeller, and it will be fitted between the impeller and the shaft, or another wear can be it will be fitted between shaft or impeller. That is, it will resist the wear to it will prevent the wear of the parent material. At first, it will be wear, and then it will allow to wear the parent material.
It's made up of
I think that
a
is.
more softer material, right?
Yes, softer material than the parent
Than the
material.
parent material, yeah. Okay. Does anybody have to add something in this answer? Akhil? Akhil, are you there?
Yeah,
Yeah. Do you want to add anything else in this answer?
yeah, it doesn't allow the flow of water from the high pressure discharge side to the low pressure suction side, back to the suction side.
So where is this uh, ring fitted?
Yeah,
Where is this wiring fitted?
it's fitted between the shaft and the casing.
Shaft and the casing. Or it can be fitted in the impeller and the shaft too, right?
Yeah,
So I have one doubt here. I have read somewhere that
Which
both
ring? Which ring? Where ring?
wiring, yes.
Where ring?
I
So
have
it
read
is fitted between the casing of the pump and the impeller.
casing
It is
of the
not between
pump,
the shaft and the impeller. Yeah, yeah. Casing of the pump and the impeller.
casing of the pump and the impeller.
Yeah, yeah.
So it's
So at the suction side of the suction side of the impeller and the casing
suction
vents
side
the
of the
back.
impeller and the casing. So
Yes,
we can say like it's fitted in between the shaft and the casing, right? So the correct answer will be it's fitted between
that
the
is stuffing box. That is stuffing box.
okay.
What you are speaking is stuffing box. This
Yes,
is different.
yes, correct. Okay. So where is an O-ring fitted in a centrifugal pump? Can anybody answer where is an O-ring fitted? Kamlesh?
No, actually, I couldn't find the answer about the
Me too,
coding,
bro. I was
but
right before this session. I was trying to find the answer, but I couldn't find where is the O-ring
yeah,
fitted.
I couldn't find anything that is
That
satisfactory enough to me, so I don't have anything to present here.
I think it is in the
is a
mechanical seal.
wrong question.
It's somewhere in the mechanical seal.
Sorry?
That is wrong.
It's somewhere in the mechanical seal only. This O-ring
In
is
mechanical
fitted
seal.
commonly in the mechanical. Yes.
Okay, but I think we have to find this
Its main
answer.
function is to prevent leakage. Prevent leakage, I guess.
Yeah, bro, is right.
Okay, it's fitted in mechanical
Uh,
seal.
Yeah, and also in shaft sleeve. Only in these two places you can find O-ring.
Okay, it's fitted.
O-ring means the black ring thing we use generally for sealing purpose, right?
Yeah, it can be other material also, not just black.
I mean, in general purpose, we see that black Teflon thing.
Yeah, yeah.
So can you please tell us more about it, where it's located, and main purposes about it?
Bro, it is only located in your mechanical seal. That's all. and also
Okay.
in your shaft sleeve.
Okay.
Mechanical seal and
Which
shaft
shaft?
sleeve.
Which shaft sleeve?
Yeah, in shaft
Which
sleeve.
shaft sleeve
Yeah.
of the same stuffing box only?
Pump shaft will have a sleeve which will also rotate along with
Okay.
the shaft. So inside that there will be a O-ring to prevent the leakage.
Okay.
Okay, so in case of mechanical seals, instead of using that stuffing material, we are gland packings, we are using O-rings.
No, no, no.
Somewhat.
No, mechanical seal have many parts, not just O-ring. It will come with a spring and a O-ring.
Okay.
And yeah, there are two parts. One is rotating part, other is stationary part.
Okay.
For that, you need to understand the working of mechanical seal.
Yeah, so I'll go through that once.
Okay. So I think we've got the answer.
For the rotary part, it is inside the this no shaft sleeve.
No,
Harsha?
rotating part will be rotating with the shaft. It will be on the shaft only. Yeah.
Yeah, on the shaft only, no, in between the shaft and the rotary part.
Yeah.
So that O-ring will be there. So basically two O-rings for a mechanical seal.
Yes.
Okay.
One will be inside and one will be outside of the mechanical seal, right?
Bro, you can just tell O-ring is present in mechanical seal and other is present in the shaft sleeve. That's all. No need to worry.
Okay. So what is the stuffing box?
You're asking me?
No, just in general. Can I please explain what is a stuffing box? Guys? Okay, can you
Well,
explain?
I can try if no one is trying
Yeah.
for it.
Sure.
Yeah, so basically, stuffing box is a sealing arrangement which is provided between the casing and the rotating shaft of the pump. Okay, so it has multiple slots in which we feed that packing material, which is either made up of graphite or Teflon. So what we are doing is we stuff that gland packing between these two. Uh, it is something like what we call flanges. Okay.
Yeah.
Yeah, so we put it in and we tight the bolts. So it provides the tight sealing between the casing and the shaft. Basically, I had diagram somewhere, but I couldn't find it. I'll post the diagram on the group
Yeah, sure.
afterwards. Yeah.
Does anybody else wants to answer this question? Or I'll move on to the next question. What is the lanterning? What's the function of the lanterning? Guys, anybody want to answer? What's the function of the lanterning?
It cools the gland packing. It also lubricates and it also seals. So there are three main functions of a lantern ring in the stuffing box.
Okay. Yes,
Yes.
Gaurav?
Link is a metal link which will be fitted between the gland packing and between the gland packing, and it is fitted over the shaft, which is give the three functions. One is cooling purpose, and one is the lubrication purpose, which is taking the outside or discharge side from the liquid, and it will put there, and it and this water will lubricate the gland packing and the cools the gland packing also. And another is the cleaning purpose. It will be used inside the stuffing box. That is the main function.
To remove the impurities, it acts as a flush point, right?
Yeah.
Okay. So
Yes.
it flushes out the impurities that can get into the gland packing through the stuffing box. Correct? Am I right?
Where does these impurities come now?
I think through the stuffing box, the impurities can get into the gland packing. and
No,
this
if
land.
water can pass to minute water particles can pass, but how impurities can pass?
No,
There can be leakage, right?
it
But
won't
there
pass
can't be
through.
any.
It can get into the stuffing box, correct?
Okay, okay,
So
okay,
this
okay.
lanterning will act as a flush point. The liquid will flow through the lanterning, and then it will protect it. It will remove the impurities, right? Okay.
Yeah, yeah. We move on.
Yeah. Kamlesh, you were going to explain it, right? With the image.
Yeah, I've shared an image
Yeah.
of a stuffing box. Okay. So in this image, you can see on the left side, we have impeller. This at center, we have shaft. And these blue things you're seeing here are packing rings, which are made up of either Teflon or graphite. By tightening these nuts, gland follower nuts, we squeeze these what is it, a gland like packing rings, and this like gets pushed against the shaft and the casing. So this prevents the leakage of water through the impeller or like from this part. Okay. So lantern ring here, you can see lantern ring basically is a slot provided through which water water is flowing. The water is taken from the discharge side of the pump, and one connection is given to this stuffing box. So there are two main functions. First one is it provides a sort of lubrication, and second one is it provides cooling to the packing ring and slightly increases their life, and also the shaft's life. I doubt if it is flushes out the impurities, but if it does, the impurities are coming because of the friction between the shaft and the
I think the impurities are
packing rings.
getting in from what's like in the image. You can see that gland follower, right?
Yeah.
I think the impurities can get through that side.
No, but do you have any
Yeah, actually, I have read it
reference?
somewhere. That's why I was saying it. I can
Okay, okay.
share the reference.
Yeah, that will be better.
Yeah. I'll just share the reference. Yeah. Should we move on to the next question?
So, Kamlesh, this water
Yeah.
that comes, it flows over the gland packings only, or just it moves along the diameter of the shaft and then it moves like from the lantern ring, or does it cool the
No,
even the gland
see,
pack?
it can move. It can move around like in this area. It also
Okay.
cools like yeah. It
That,
is
but
connected to. I
that
think I
will lead
haven't
to
seen it
leakage.
physically.
That will lead to leakage,
See,
right?
I think in
uh,
a centrifugal pump there is a little bit of
uh,
leakage, right?
yeah,
Yeah, but yeah,
stuffing box
purposely,
doesn't provide
but you,
100% of leak proof.
Yeah.
It's not
yeah, but you're
100% leak proof.
purposely piloting and from the discharge side to this lantern ring, no? So I don't
See,
think
if
so.
you are
It
not
goes.
putting lantern ring, then the shaft will get overheated because of friction between these packing rings and
Yeah,
the
yeah, yeah.
shaft. Okay.
Okay.
So that's why you need something to cool it off.
But I don't know if it moves around the gland packing on the rings.
Yeah,
I
yeah,
think
yeah. I
it
also
only
have
moves
little bit
from.
doubt about it.
But it is fabric, no? It should go inside, I think. Sip inside the fabric.
Yeah, yeah, yeah. It does. It does.
Yeah, I think it seeps inside, correct? Like
Yeah, I
it.
think
Yes, yes. It
we.
should sip, and
Yeah, it
because of
should
the
seep
tightening
inside.
effect, then it gets drained. I think because of the tightening effect, no, it gets drained. I think
Yeah,
it
correct.
does into the lantern. Yeah.
Because it is the gland packing is wrapped around the
Uh,
shaft, right?
Yes, yes,
Okay.
yes.
yes.
Yeah. Move on.
So, can you anybody explain what's the working of a centrifugal pump? First, what are the classification of pumps? Anybody would like to answer?
So we
Can I
have
tell?
two broad classifications. So
Yeah.
we have rotodynamic pumps, then there are positive displacement pumps. So under rotodynamic, we have the centrifugal pumps and the axial flow pumps. While coming to the positive displacement pump, there are rotary types and the reciprocating type. Under rotary, we have the gear pump, vane pump, block pumps. While in the reciprocating, we have the piston pump. Under piston, we have the single acting and the double acting. So this is the classification.
And you can add diaphragm pump, correct?
Yeah, I forgot about
Yeah.
diaphragm.
Yeah. So can we explain the working of a centrifugal pump?
Can I?
Yeah.
Initially, impeller is surrounded by fluid. When impeller start rotating, fluid also start rotating, and cast out readily outward toward the casing because of centrifugal force act on the fluid. The centrifugal force act on the fluid, which fluid flows outward the cast out readily outward to the casing, and then vacuum pressure is created in eye of an impeller. In vacuum pressure is created in eye of an impeller, so there is a suction created, and then fluid flow circumferentially outward toward the discharge side. The casing area of the casing is gradually increasing to the discharge side. When the area increases, velocity decreases according to equation of continuity, and then velocity decreases, pressure energy increases according to Bernoulli's theorem. This is how discharge pressure is created in discharge side of the centrifugal pump.
Okay. Anybody else want to answer?
Can I try?
Yes.
So when we start the motor, the shaft connected to the motor rotates, which is further coupled with the impeller shaft, which rotates. This causes the impeller to rotate, which causes the fluid in the casing to move radially outwards due to the centrifugal force of the impeller imparted onto the fluid. This causes a wide space at the eye of the impeller, which causes a negative pressure at the eye. That's how the fluid gets sucked. It moves along the volute casing. So design of the volute casing is such that the cross-sectional area goes on increasing. So the fluid that gained the kinetic energy gets converted into pressure energy as per Bernoulli's theorem. So this is how a discharge pressure is created at the discharge side of the centrifugal pump. This is how a pump works.
If they are asking the question, like explain centrifugal pump, then everybody should explain everything, right? How is the suction pressure getting created? How is the discharge pressure getting created? Am I right? Or should you just make it short? Then he will cross question on how is the suction pressure getting created or how is the discharge pressure getting created?
Yes, preferably you should explain both suction discharge.
Okay. But then the cross question, like you won't be able to cross question, right?
Depends, no. If he wants, he can.
Yeah, correct. I think yes, you are right. We should explain it fully.
Me, then you should answer. I mean, yeah, exactly. Can I try explain it once?
Yes.
Yeah, okay. So there are two major components in an centrifugal pump. One is an impeller, then second is the casing. Okay. Uh, the suction part, pump sucks water from the eye of the impeller. Okay, as the impeller is connected to the motor and motor or like a driving component. So as the impeller rotates, it imparts its rotational energy to the fluid present inside the casing. Because of the centrifugal forces, the fluid moves away from the center towards the like circumference of the casing, and this creates a void at the eye of an impeller. So this is creating suction pressure in our pump. Okay. So the what like liquid, let's consider it as water, which is moving away from the center, flows through a volute casing of a pump, in which the area is gradually increasing. Okay, so as the area is increasing, velocity decreases, and the pressure energy of the liquid is increasing as per the Bernoulli's principle and continuity equations. Okay, so then this water with high pressure energy is then discharged out at, tangentially to the outlet port or discharge side of a pump.
Yeah,
Yeah.
correct. Is it tangentially correct? Saying at the discharge side it is thrown tangentially outwards? And I have no idea
Yeah,
about
I
it, but
used to
it's
say it
like
radiate.
99% it's tangentially.
Yeah, it's
Okay, okay.
Yeah. I think what's the difference between radial and tangential?
Almost 99% centrifugal pump has a tangential discharge.
The backward curves helps to radially output in impeller.
Sorry, what?
Uh,
It's not the backward, it's the centrifugal force of the impeller onto the fluid. Even if you have forward vane, it will still be throwing it radially outward. So it doesn't matter if it is radial or no, sorry, if it is forward, backward curve vane. So it's because of the
No
centrifugal
answer.
force.
It does matter.
Yeah, yeah,
It does matter. It does matter if the vanes are forward or backward. Okay. So see,
okay,
okay.
if if the vanes are forward curved, then what will
yeah,
happen? It will create more turbulence inside the casing, and this will lead to the cavitation. That's why the vanes are backward curved.
okay. But in the forward type of this impeller, where will the fluid be thrown? It will be thrown radially outwards, or so that's what I mean.
No, no. Fuel will see what will happen.
Yeah,
Okay, let's imagine a phenomena where you are rotating the pump in the opposite direction. Okay.
okay,
So generally the fins of the impeller are like curved backward. Okay. So what's happening if the vanes are curved forward, like in the direction of the rotation, then it churns the water and creates turbulence. So it leads to the like drop in the local pressure and it creates like cavitation, which damages the impeller. So when the cavitation is happening, your discharge is reduced. So the efficiency of your pump will be reduced drastically. You getting me?
yeah, I got you. But how will be the water be thrown? It will be thrown radially, from the
Sorry.
impeller eye to the discharge of the this impeller from this, yeah, suction to the discharge. It will be thrown radially outward, Like if you consider the
No, no,
circle
no.
as the impeller, from the radius
Uh-huh.
will be out from
I
the
didn't
eye to,
actually get you.
okay.
He is saying that radially pushes the outward the fluid toward the casing.
I mean, it doesn't matter, no, if it is
Yeah, the fluid
like,
will be.
oh, yeah, radially outward, it will be moving. The fluid will be moved radially outward. Doesn't matter
Yeah,
if it
it
is
will
forward.
be pushed radially outward. But what's
Yeah.
happening in this case is you will see there is increased
Yeah, that I
cavitation.
got. Yeah, turbulence and all I got.
Huh.
But it will be thrown radially outwards. Doesn't matter.
But backward goes, it helps for traps the more fluid and then smooth flow of the fluid, right?
It reduces the
Yeah,
vibration, right? But
cavitation.
it reduces
Yeah, let's move
cavitation.
on.
Okay.
Otherwise, we'll get trapped over here only. Let's move on.
Okay. So what is
Okay, is this coming in the recording? Sorry.
yeah, yeah. What were you saying? Kamlesh, you're saying something?
No, no, that's what I was saying. Yeah, the veins should be like backward curve.
Yeah,
Radially. Okay, someone is saying radially pushes outward.
yeah. Shashank was saying something. Like, it's right. Radially out will
Radially out
pushes
push more
more
water.
water outwards. Okay, so if it will be radially, then more water will be pushed outwards. But how?
I didn't get it. What exactly happening here?
I have a doubt
Let's
here.
discuss this in the next session.
Yeah,
Let's
yeah, yeah,
research about it and let's discuss.
yeah, yeah.
Yeah.
No, it's
Move on.
no, it will get.
Should we move on? What's Gyan's video on centrifugal pump here taught by showing a diagram. Okay.
Okay. Uh,
I have seen his video, but I think I have forgotten. So
Let's move on, no? Surprise.
let's move on. Okay. Okay.
Yeah.
Which pump is used on pump boiler feed water?
Same
Can I tell?
centrifugal.
Centrifugal pump. Yes.
it's
Centrifugal pump.
centrifugal pump.
Centrifugal pump.
Yes, correct. Centrifugal pump. What is NPHs?
Net positive
Net
suction
positive
head.
suction head.
Can anybody explain?
It is the selection criteria. It tells whether the pump will work without cavitating. So the suction pressure at the suction side of the pump should be higher than the this vapor pressure of the fluid present. So this is the and also NPSH available should be higher than the required, which is given by the manufacturer.
And the formula for calculating NPH is available. Can you tell me the formula?
No idea about it. But this is asked in IMS. This is asked. No, I guess no.
Yeah, I think this is not asked because in the testimonials, NPHs is I think not mentioned. But centrifugal pump and
But can be asked. Can be asked.
yeah, it can be asked. NPHs is a common question actually.
Yes.
The
Absolute vapor.
yeah, please
Absolute suction
share
pressure.
formula.
Hello. Yeah. Absolute suction pressure plus minus friction losses and vapor pressure minus vapor pressure. That is.
Okay, absolute suction pressure plus or minus water head minus frictional losses minus the vapor pressure. Correct. Absolute vapor pressure. Am I right?
Yes. Yes.
Okay.
Now audible.
Yeah. Now you're audible. Can we explain the differences between a centrifugal pump and a positive displacement pump? Who would like to answer it?
Can I?
Yes.
First, aside the centrifugal pump and positive displacement, first basically an operational principle. It works. Centrifugal pump work on a principle of converting kinetic energy into potential energy by using impeller to create centrifugal force. In positive displacement work on a principle of trapping a amount of fluid in a chamber and use the pressure. After the flow rate, in centrifugal pump provide a stable flow. In positive displacement pump, they provide a relative constant flow of in that pressure handling. Centrifugal pump has better suitable for high flow and low pressure places. And positive displacement pump is used for high pressure and low flow. Coming to viscosity, centrifugal pump works well with low viscous fluid, and positive displacement pump works on both high viscous and low viscous, but efficiency may be differ. After the centrifugal pump required priming, positive displacement did not require priming, and the maintenance cost is compared to centrifugal pump. Positive displacement pump is high, required more area compared to centrifugal pump. That's it.
Yes. I think you have mentioned Maxima. Have you said about relief valve?
I did not hear.
Yeah, relief valve is not required in centrifugal pump and it is required in positive displacement pump. Right? Have you?
Yeah. I need to add.
Anybody else wants to add a few more points? Akhil, can you?
Can I?
Yeah, sure.
Okay, so centrifugal pump is a type of a rotodynamic pump, while a positive displacement pump is a sorry. The working principle of a centrifugal pump works on the centrifugal force, wherein suction is created at the eye and then the discharge is created because of the centrifugal force. While we have positive displacement pump, which traps a specific volume of fluid and then positively displacing it. Now, for the centrifugal pump, we require priming, while for a positive displacement pump doesn't require priming. A centrifugal pump, we the rotary part is the impeller, while in the positive displacement pump, we have the rotary parts such as gears or screws, etc. In the centrifugal pump, we have a relief valve. No, sorry, it doesn't have a relief valve. while in a positive displacement pump, because of the high pressure created, we have a relief valve. These are the points of difference.
I have also added 3 points like centrifugal pump requires less space and positive displacement pump requires more space. The initial cost of a centrifugal pump is less. The initial cost of a positive displacement pump is higher. If you want to, you can add those points too. Your answer is correct. So,
Space, how we can, how space can be a factor, like gear pump, if you consider, positive displacement pump and a centrifugal pump, both will take the same space. So you can't say space.
okay, I think centrifugal pump it's not smaller, right?
If you say reciprocating and then a centrifugal pump, then space can be a major point of difference. But you can't say with the
Okay,
positive displacement pump because it can have, even have a gear pump, so it has a like enclosed structure, no, where gears are fitted. It
okay.
can be same as the centrifugal pump. So
So
you can't say space.
we can only say when it's like when we are comparing centrifugal pump and reciprocating pumps, correct?
Correct, because it
Okay.
will have its connecting rod and that other stuff, all of
Yeah,
these
yeah,
crankshaft and also it will require higher space.
got it.
Got it, right?
Yeah, yeah, got it. So, uh, anybody else want to explain, or should we move on to the next question? I think let's move on to the next question then. What a negative displacement pump? What are negative displacement pumps?
I did not find anything about it.
I
Have you
think
got?
we can
Kamlesh, you got
say that
anything?
centrifugal pump is a negative displacement pump, right?
How? How come?
Like positive
It's a
displacement.
rotodynamic pump, no? Rotodynamic pump, no? It works on the rotational energy of the impeller.
Yeah, but positive displacement pumps are those pumps that traps a fixed amount of fluid in its chamber, then pushes it out by
Yeah,
mechanical
and
arm.
then yes, yes.
So
So how centrifugal will be negative then?
no, I don't have like I also have a doubt in this question. I was asking, we can say it or we can't say it because I also didn't got anything.
I think the interviewer was testing the interviewer's knowledge, I think.
Yeah, this question I think only asked in interview
And
negative
yeah, yeah.
displacement pump because I have not seen it anywhere else. So what should be the correct answer?
I would say there were no that like there is no negative like this
Displacement
negative
pump.
displacement pump. Yeah, yeah. He was testing his knowledge maybe. Whether
Maybe,
he
yeah.
was saying something or
Because every pump
like that.
displaces some amount of fluid, right?
If it displaces negatively, then what's the use of using a
Yeah, yeah,
pump?
yeah, correct, correct. Can anybody explain the working of a gear pump?
Or can it be like vacuum or something? Negative displacement pump means like
Just try
vacuum
to find the
creation,
answer, but I was not getting any
Yeah,
proper
can
answer
be.
regarding negative. Like it's not, there's nothing like negative displacement.
Yeah, yeah. That's what I was searching. Yeah, let's move on. Wait.
Yeah, I think this was just a one-time question, maybe. Who can explain the working of a gear pump? I just have one answer regarding negative displacement pump. I will share it in the group. That was not in any website and all. It was just in Quora. So can anybody explain the working of gear pump? Anyone?
Can I go?
Yeah.
When two gears getting out of the mesh, there is a vacuum pressure period. When area increases, pressure decreases, and there is a vacuum pressure period, and then fluid get caps into the gears gears, and then it circumferentially move outward to output toward the casing, and then discharge is created, getting into the mesh. When fluid is getting into the mesh, area decreases, pressure increases. This is how discharge pressure created, and then discharge of fluid is happening.
Yes, you are right. I think you can add the like before the suction pressure is getting created, you can add this part too. That there are two gears. One is the driver gear, one is the rotor gear. Both are meshed with each other, and when the motor converts electrical energy to mechanical energy, which rotates the shaft, rotating the driver gear, and the follower gear follows. And then we can say that when the gears are rotating, when the gears are coming out of the mesh, the area is increasing, due to which pressure is decreasing, and as negative pressure has been created, the fluid enters and then it flows towards the casing, right? And it gets trapped in between the gears and the casing. Am I right?
Yeah.
Can I
Yes,
try
yes.
to answer it in the other way?
Yeah.
Similar, but I have the more structured answer, I think.
Yeah.
So see, in external gear pump, we have casing and two gears meshing with each other inside the casing. Okay, one of them is driven by a prime mover, or maybe it can be a motor or something, and another is a driven gear. Okay, so at the suction side, the gears are coming into the mesh, and at the discharge side, gears are coming out of the mesh. So when the sorry, I just misplaced it.
At the
Right?
opposite way.
Sorry.
The
At
suction.
the suction side, gears are coming out of the mesh, and at the discharge side, gears are coming into the mesh. Okay. So when gears are coming out of the mesh, the volume between the gear teeth is like increasing, which creates a vacuum at or negative pressure at the suction side. So the liquid is drawn inside pump casing. Then uh, this liquid, which is coming inside, gets trapped between the walls of the casing and the gear teeth, and then it is transferred to the discharge side of the pump. Okay. Over there, the teeth are getting into the mesh, which is reducing the volume and hence increasing the pressure. Hence, we get high pressure at the discharge side.
Yeah, this is a much well structured answer. So any cross questions regarding gear pump in the testimonial? I don't think there are any cross questions regarding gear pump. Yes, one.
Correct.
What if the gear pump is reversed? Then what will happen? Anybody?
I don't think there will be a major issue. The pump will start pumping in the reverse direction.
Yeah, I think that's it, right? If it's
But
reversed,
there can be some issues regarding the safety of the pump because the safety valve is at the outlet of the pump, right?
yeah.
No, Kamlesh, there will be
But
difference.
suction will not take place,
See,
right? Because the
see.
yes,
Okay. Answer.
Samson, yeah.
So motor is connected to the driver gear. So previously, if it has to work in the counterclockwise direction, so now
Mhm.
if the motor is reversed or the gear rotation is reversed, that means it rotates in the clockwise direction and the driven gear rotates in the counterclockwise direction. Due to this, the suction side becomes the discharge side and the discharge side becomes the suction side. You can see drawing by drawing the diagram on the piece of paper. You can see that suction side becomes the discharge side and the discharge side becomes the suction side.
Yeah,
So
that's what I
the
said.
flow will be
It won't change
uh,
much. Only the pump will start pumping in the reverse direction. That is, suction
So
will become discharge and discharge will become suction.
will the
That's what
suction
I mean.
take place when if it will be reversed? Will suction will take place or it will not take place?
It
of course it will
will,
take place.
It will take
It
place,
will
right?
take place. Yes.
Oh,
yeah, but can anyone just tell me, like, there will be an issue with the safety valve? Correct me if I'm wrong. The safety valve is generated located at the out, outlet of the positive displacement pump. Am I right?
yes.
Hello?
Yeah, correct. Yes.
Yeah, so if the direction is getting reversed, then in reverse case, the safe valve will be at the relief valve will be at the inlet of the gear pump,
Yeah, correct.
which will make no sense. So in longer operation, it's not recommended.
I think, have you wrote down a perfectly structured answer for this question? Do you have it?
Actually, I haven't wrote down the answers, but I had notes
Okay.
I prepared in the past.
So, what are the types of packings used?
The gland packing and mechanical seal.
Yes, and differences between both?
Which gland packing is a type of material? Which I need to say the differences.
Yeah, differences between a gland packing and a mechanical seal.
Yeah. The mainly difference is it is very cheap. Gland packing is very cheap compared to mechanical seal and easy to replace. And use it in low viscous fluid pump. That's
Yes,
it.
you are right. But
Is it just me or Vijay? Can you be
Yeah.
a little loud?
Okay. It's very cheap compared to mechanical seal and also easy to change.
Any
And
other
use it
points?
in no, that's it. Bro.
I think if this question is coming, first we should explain the structure, right? Like the gland packing is twisted fibers uh, that are wrapped around the shaft, which is fitted inside the stuffing box, and the mechanical seal is a two-piece component. One is the rotating part and one is the stationary part. Rotating part is fixed at the uh, shaft, and the stationary part is fitted with the casing. I think we can explain in that way, right? Then the points.
Guys, just a
But it
minute.
is only asked to the types of packings, right? So you have to only tell the packings. Then if it is asked,
Like
explain me the gland
differences
packing, then
between
you have
both.
to be more specific. You said differences?
Yeah. Like first I was asking him
Okay.
types, then I got into differences. So if he's
Okay.
asking differences, we can explain this way, right?
Yeah, you can explain now.
Yeah.
Oh,
Then
sorry for interruption.
yeah,
Just
sure.
can someone please repeat the types of packing? I didn't heard properly.
Vijay only had said
Gland
So it
two
is
packing and
gland
types.
packing and mechanical seal.
mechanical
Are the
seal.
two types of packing?
These are the two
I don't
types,
think
right?
that's the right answer for this question.
Okay.
Why it's wrong?
No, it's not completely wrong.
Okay.
I
Oh,
think what the question means is, see, there are multiple types of gland packing. Uh, I mean, the material which is being used
yeah,
for the
okay.
gland packing. Okay, one
Okay.
like there is graphite, there is Kevlar. So for general purposes, we use graphite gland packing, and for special purpose like some corrosive chemicals are there, then we are using like a Kevlar material gland packing. Okay, that's what the question
Mhm.
is, I think, because of it is being followed by the question conditions based packing preferences.
Yes, condition-based packing preferences. Yeah, that was the question. What I didn't understand this question. What was it? Condition-based packing preferences.
Yeah, so condition based packing preferences means, let's say you have
Yeah.
two pumps. Okay, one pump is pumping regular water, and the second pump, which is pumping some corrosive chemical. Okay, so for regular pumping water, you can just use graphite packing. Okay, it's comparatively cheaper. But if you're using some corrosive liquid which is being pumped by your pump, then you must use something like a more like special purpose, like a Kevlar or a carbon fiber packing, which is which can withstand the corrosiveness of the nature of that liquid. So it will be little costlier as compared to a graphite packing, but it will get the job done.
And if the fluid is harmful, like,
Mhm.
then we can't use gland packing, right? Then we have to use a mechanical seal.
Yeah, for some specifically really I mean, like there are some like liquids where we are using mechanical seals instead of stuffing boxes.
So if this question will come condition based packing preference, then we can just give this answer, the types of gland packing that we use. Correct?
Yeah, that's what I think.
Okay. Yeah, because this question I have never heard it before. I was also
So this is the answer for the types of packing, the condition-based packing preference.
Yeah. But still, if you have any sources, then please go and confirm this and update on the group. But this is what I think this should be the answer for this question.
And even if types of packings are, so that is the answer, right?
Yeah.
Okay.
we can also add the mechanical seal too, right? Because that is also a type of packing.
Maybe.
Yeah, I will try to put the answer to it.
Just try to get get through it.
In pumps, any more different questions at least when packing them. How do we start a centrifugal pump?
Discharge valve closed.
Can anybody explain how to start a centrifugal pump?
Can I?
Yes, please.
First of all, when we start centrifugal pump, we check it out first. You need to check all the discharge valve. After that, if any coolant is present in the if you need to prime the pump if necessary, depending upon the condition. And then we need after the starting the pump, after the pressure build up in the pump, we need to open the discharge valve depending upon the condition by partially or fully.
Okay.
I think it,
Anybody else want to answer this question?
Can I?
Yeah, please.
Initially, discharge valve is closed while starting the centrifugal pump. It can closes up to 15 minutes maximum. When the impeller is attaining the standard RPM and then torque, the discharge valve is slowly open. The flow will increases and then current also increases. Am I correct?
Yes, you're right. The question is how to start centrifugal pump. Can we add this part too, that if the priming is required, then we can do the priming too?
Yeah, there is a two types of priming.
Yeah.
Manual priming and then reciprocating. Using reciprocating pump, we can prime the pump.
So if this question will come, what should be the answer? So we can add priming too, correct, Hamster?
Yes.
Okay. So can anybody
I'll
give a
suggest.
structured answer?
Yeah. I'll suggest don't go into explaining the priming in the same question. Okay.
Yeah.
If I have to answer the question, I'll go like this. When you're starting a centrifugal pump, make sure it is primed. Then make sure the discharge valve is closed. Then you start the motor. Wait until it reaches a certain RPM. Then open the discharge valve slowly. Okay. So maybe after this, you will face some cross questions like why you are closing this discharge valve. Anyone would like to answer this question?
Yes. Please go on.
Okay. I'll try. So see.
You are asking me, or I didn't?
Yeah. Anyone else?
Yeah. Okay. Anyway, anyone else wants to answer this question, or should he continue? Gaurav?
What is the question? Hello.
Why do we keep the
Why are you
discharge valve?
closing the
Yeah.
close while starting the centrifugal pump?
Okay, we are closing the discharge valve start because of the current drawn in the initial position is the low. That's why we are centrifugal pump discharge valve will be closed, due to which when the discharge valve will be slow, at first when the pump will be started, the starting torque will be required to from the rotate the stationary position to a constant RPM. That is already required a higher amount of current, And otherwise another, when the discharge valve will be open, the discharge will be taking place. That is the another one resistance, head resistance will be acting on the impeller, and that is the more current will be drawn by the pump. That's why the windings can be damaged. That's why we are ensuring the at first discharge valve will be closed at first starting time. Then we gradually open the valve to starting the flow. That is
Yes, Gaurav, you answered it properly. Just you messed up one thing. While starting the induction motor, it will be drawing more current. You said
yeah.
it will be drawing less current. So if you see
Yes,
the
yes.
discharge
I will,
versus current graph of a pump, then you will
yes,
see that
I will told the starting torque will be required. That's why the only one point means the current will be also
yeah, you the after the answer
stored.
you said
That
it
is,
properly. You
sorry.
just missed uh, said the only thing that like if
Yeah,
you should be setting high current, you said low current. That's it. Otherwise, the answer was right.
Yeah, yeah.
yeah.
Okay. Kamlesh, you would like to answer it, or should we move forward?
Yeah, it was pretty much same. While you are starting a motor, it will be drawing high current because it will need high starting torque to start the motor. So if you are keeping the discharge valve open, if you see the discharge versus current graph, then you will see as the discharge increases, the current drawn by the motor will be increased. So if you are keeping the discharge valve open, then this discharge will also draws more current for the motor. This will lead to damaging of the windings. So that's why we keep the discharge valve shut and then start the motor, start the pump, and we open the discharge valve after it reaches a certain RPM.
So I think we have almost covered the IMS testimonial questions. Does anybody have any other questions regarding pumps? I think late we should continue in next session. Yeah, because it's almost it's going to be 2 hours. Does anybody have any
I will
other
continue
questions?
next time.
Yeah, yeah.
The workshop thing and the IC part.
Yes, yes, yes. Okay. Thank you so much. So,
Uh,
anybody else has any other questions?
Before Sarfraz, I just want to ask one thing. Are you recording by parts?
By what?
By I mean the topic-wise parts you are recording, or you have recorded the entire
No,
video
I
every
got the
single video?
message a little bit late, so I recorded the whole session.
I did the same thing.
Yeah, me too. He messaged just now. He just messaged me just now that try to record it part by part. I recorded the whole
Uh,
session.
I think we have to cover it at editing parts.
Yeah,
Never mind.
So while
We'll
they
see about it later.
Kamlesh, while they ask for RAC components and VCRS components, are they not same? So RAC is based on the air conditioner.
I
Is it
think
like that?
we should just
See,
add two
RAC
more
means
points.
refrigeration and air conditioning.
Yeah.
Okay.
So if they are asking RAC, what I think they are asking is you are supposed to explain the VCRS system. That is uh, vapor compression refrigeration cycle.
Yeah.
That's
So it's
what
the
you are
same.
supposed to explain.
So it's the same thing.
Yeah, it will be the same thing, except in the air conditioning system, you have streamlines to like raise the temperature and what else?
Dryer. Sorry, the
The
humidifier.
humidifier,
Humidifier.
yeah.
Yeah.
Hmm.
But I think that's a separate component. It doesn't comes under the RAC section.
Okay.
It I think it comes under HPAC or
So
something, but I'm
better
not
to
pretty sure about
explain
that.
the parts of the this, no? Air
Yeah,
conditioner.
VCRS. Go with the VCRS.
Okay. With the VCRS.
Yeah.
Okay. Thank you.
Okay. So I think we have wrapped up pumps. So I'm going to close the recording. Thank you so much, guys.